So in this example, I wanted to do something that was a little bit inspired by some of these kind of bubbly balloon-like looking features that you'd see in this one of my favorite commercials of all time, the Nike Air Max 17, where we've got these bubbles and particles and just a bunch of really just awesome type things. So I think what we're going to kind of do is try and tackle like something kind of a combination of this like effect here where we've got these little bubbles kind of flowing around inside of the shoe, and then kind of finish it off with this sort of inflation that's happening right here where the bubbles sort of increase and kind of take on the shape of the shoe. So in order to do all of this, we need a shoe model. And I've included a shoe model in the project folder. So let's just throw down a file, or let's throw down a geo node. I'm going to name it shoe. I'm going to jump inside here and then throw down an alembic. That'll allow me to import my shoe. I'm just going to click this, and then in here I've made an ABC import folder. Double click that and select shoe scan version 2. Accept. So this is a shoe that I scanned for the purposes of making this tutorial. It's really cool, actually, believe it or not. If you follow this little thing right here, this is a page on the Side Effects website. Side effects /tutorial /Alice Vision plugin. If you kind of search for photogrammetry in Houdini or whatever, you'll find this. And this basically will give you a little bit of a rundown of how you can actually get the game tools installed and get this get the photogrammetry plugin installed. And more or less what it does is it creates a node for you that you can point to a folder that you can point to a series of pictures on your hard drive, and it will generate geo for you. Now this mesh I generated using only like 60 iPhone photos, and I hung a shoe from a coat hanger and then from a chandelier in my house, and this is what I got. It isn't like the best mesh or anything like that, but it's got the general shape of a shoe, and it's going to work great for us since, looking back at our Air Max reference right here, we don't really see a shoe. We're just going to be putting bubbles inside of the rough outline of a shoe. So we're going to just go with this, even though it looks pretty gnarled up. It should give us a good basis to start from. So let's process this shoe and get it ready for our simulation. I'm going to hit the D key and do my usual thing of turning my origin gnomon off and turning my background to dark. Not totally optional, just the way I like to do things. So let's just convert this into a poly. Throw it on a convert. And wire this in here. And it should give us a wireframe of our scan geo, which is good. And then what I want to do is I just want to kind of create a smoother version for our collision. We're going to be using this as like a hull for our collider. And so I just want to create sort of a smoother hull for collision than what we have here. You can see it's a little bit chewed up around the edges and stuff like that, and there might be some corners and stuff I don't really want things to get all stuck inside of. So I'm going to just throw down VDB from polygons. One of my favorite ways to both down res and smooth out geo. So I'm going to grab that, wire that in there. I'm going to do we're going to leave it at this voxel size of 0.1. You can see it's genericized the living daylights out of this shoe already, which is great. And then I'm just going to convert it back to a polygon using a convert VDB. And I'm going to set that back to polygons. And you can see that it has created a pretty coarse low res mesh for us. Which this should just work fine for colliding with our geometry. It's just it looks like it's going to be pretty manageable. Maybe I'll throw it on a smooth and see what that does after the fact. This may or may not help. Yeah, I'll do a smooth. That just kind of rounds it out even further. And if I template the other shoe, it looks like it's adhered pretty well. I'm going to call it close enough. I don't know if this smooth doesn't do too much in terms of making it not. Yeah, I think we're in good shape here. So let's just throw it on a null, and this will be our collider geo. The next thing I want to do is actually scatter some points throughout this so that we can initialize our bubble geometry. So let's just throw down an ISO offset in here, and I might increase the sampling divisions to 50. Good. I'm going to turn off that template flag up there. So I've got this fog that I can scatter points throughout, but I want to actually offset it inward a little bit just so that I'm not scattering points too close to this surface. So if I throw scatter down like this and wire it in, and then maybe what I'll do is actually bring the total count down to like 16. I thought seemed like a good number for me. So I got 16 points in there, and then I'm going to just throw down a sphere and a copy to points. So we can copy some points onto, oops, let's copy the sphere on the left and the scatter points on the right. The scatter points are too big, so we can actually add a p-scale attribute and randomize it. So let's throw down an attribute randomize. And randomizing p-scale will just give us a bunch of different sizes of these spheres, but we need to do not the CD attribute, but the p-scale attribute. And we'll do maybe we'll do a custom ramp, and we'll fit the value of 0 between, let's just bring the upper value down. So let's fit the maximum value of this ramp to maybe, let's fit the maximum value of this ramp to 0.1. And I don't want my spheres to go all the way down to 0, so maybe I'll bring the minimum value up to maybe something like 0.6. We'll try that for now. Now our scatter is actually relaxing stuff, which is good because it's going to help these points not intersect one another so much. But if you are getting any intersection like this, what we can do is throw down a relax, and then put the relax after the attribute randomize, because the relax will actually consider the p-scale attribute when it's relaxing these points. So let's throw down a relax. Oops. Point relax. Throw that there, and if I highlight my copy to points and select the relax and choose relax in 3D space, you can see it's kind of pushed those points apart. So again, I'm just going to turn that off and turn it back on. You can see it's pushed those points apart slightly. So the other thing is, like, I'm seeing, we did do this ISO offset so we could inset these points a little bit so that they were not like able to travel outside of the shoe so much. Yeah, I'm going to set this value maybe to 0.0, but maybe 0.1. Something like that. So the spheres are looking like they're pretty much inside the shoe. But the other thing I wanted to do is kind of mess around with the scatter seed so that maybe I can get in another one that's like closer to the toe here. So I'm just going to go through the global seed, and that looks pretty good. I'm just selecting the first global seed, and this just looks like a better distribution to me. Cool. And let's just go back to this. I'm going to just select the relax again and maybe increase the relaxation iterations a little bit more. And maybe what I can do is I can actually cheat even further by, you can see that this sphere is being pushed outside of this other sphere because they were intersecting. I could actually cheat this by gradually increasing the point radius scale, and that'll push it away just a little bit further, so that it's just ensuring more space between all of our points. But now this piece is sort of sticking out of the shoe, and what we're going to do is convert this all to a VDB and then clip it so that it's all contained within the shoe. So let's do that. I'm going to throw down a VDB from polygons, and let's wire this in here. You can see we get these very general blobby shapes. I'm going to just bring down the resolution by a factor of 10. So instead of a voxel size of 0.1, we're going to do 0.01, and we get some spheres like that. So now what we can do is actually take the shoe geo that we have up here, this VDB from polygons, and we can do a SDF intersection. So let's throw down a VDB combine. I'll wire this guy into the left, and let's go up here and grab VDB from polygons that we did earlier and wire it into the right. I'm just going to holding Option or Alt. I'm going to click a couple times to just create these nice little elbows for us to go around. If we go into our VDB combine, nothing's happening. Right now, it's got this resample. It's going to resample B to match A, which is good. That basically means that because this left voxel size is 0.01 and this voxel size up here is 0.1, it's going to resample the right input to match the left input. So that's what resample B to match A is. Good thing to note. Then the operation we're going to do is a SDF intersection. You can see it just clips. It clips off any spheres that were sticking out of this geo slightly so that they're now just sort of inside like that. Next thing I want to do is a VDB smooth SDF. Just to what the smooth is going to do is basically make it so that these aren't such harsh cutoff points right here. So let's throw on a VDB smooth SDF. Wire that right here. And now you can see these are getting to be more bubbly looking. We do have this happening. There is a intersection occurring between these two. So what I might do is just a little bit of a reshape to avoid this kind of intersection, because when I convert this back to a VDB, so say when I convert this back to polygons using a convert VDB and set this convert VDB to polygons, we get this sort of metaball like intersection happening here with a couple of these. So to avoid that, I might just do a VDB reshape. VDB reshape SCF, or the other thing I could do is actually try and relax my points a bit more. So maybe I'll do that. I'll just relax them away until they break off, which is good. Did it work over here? It looks like it worked. Cool. So I'm not going to do the VDB reshape after all, but I could have alternatively thrown in the VDB reshape, set it to erode, and eroded these away from one another, and that might have solved it as well, but we'll just use the relaxation for now. Cool. And if I need to add more points later, if I needed to change this point count, do something like that, I might want to additionally do some reshaping, but I'm going to just stick with 16 points right now. That's looking good. Cool. So the next thing now that we've got this is I want to just remesh it so we get those nice triangular patterns that we had before. So let's remesh. And we'll use a remeshing resolution of 0.02. So our bubbles look like that. Nice. So this really is going to be our input geometry. So I'm going to just put down a null and call this the balloons. Balloons to inflate. And that means that whatever wires into this node is going to be the balloons that we want to inflate for our simulation. Awesome. So now I'm going to just hop up here to the object level, and we'll go up to our vellum shelf and select vellum balloon. And it's thinking about things, and it throws down an auto.network and a vellum import for us. So I'm just going to call this balloon export. And let's just take a look at what it did for us. So if we jump inside of our shoe, it's created two new vellum constraint nodes. One of them is a cloth constraint and the other one's a pressure constraint. So the stretch cloth constraint is really going to be controlling how the exterior shell of this geometry behaves, but the pressure constraints are really going to be kind of controlling how the interior volume is expanding or behaving in these with these vellum objects. So out here in our auto.dot network, it's created a gravity node, and if I just click play, all these balloons just fall down and don't do anything. They do not really behave very balloon-like. They're just behaving sort of like rocks. But we can fix that by sort of playing around with some stuff. Let's first off add our collision geometry. So I'm going to throw down a static object. And that static object is going to be the shoe geometry we created up here. So I'm going to grab this collider geometry and just drag it into the SOP path here. And then I'll just wire it into this merge, making sure the merge is set to mutual effector. So that should all work. Now because my whole sim is going to be happening inside of this collision hall, I don't really want to see my collision geometry while I'm in the sim network. So I'm going to just go select my static object and turn off display geometry. So now when I click play, all my balloons fall down and deflate and look like a bunch of red blood cells or something like that. But they're at least colliding with our geo, so that's good. So the next thing that I want to do is sort of start to dial in this balloon-like look. I think that first off, what I want to do is just turn off gravity for right now, and then I want to work on inflating these objects. Now, in our constraints, we get these sort of rest length scale, these rest length attributes and rest length scale attributes. So if I go over to select this and I just want to view my primitive attributes, it doesn't look like I'm not seeing any right now. I got that surface, okay. If I go over to the constraints over here and I select my constraints output, you can see that this is our constraint geo. We've got our cloth constraints on the outside, and then it's kind of hard to see, but on the inside there's going to be little constraints for the balloons to do their thing. And basically what constraints have is they've got this rest length attribute. The rest length attribute basically is whatever the however long one of these little lines is, it's going to store that as its rest length, and then it'll adjust things like whether it should be pulling these 2 points together or pushing them apart based off of what the rest length is. It's constantly going to be searching and trying to compensate throughout the simulation to get back to that rest length. But if we increase that rest length, it's going to behave like it's inflating. So let's go over here and add in a new node into our DOP network called Velum Constraint Property. And in this Velum Constraint Property, what I want to do is just wire it into, I'll just wire it into the middle here. And then I'm going to actually, let's just increase this rest length scale right here. You can see there's an option to scale on the rest length. So by default, just activating that and clicking play, nothing really happens. You can see that it collides a little bit with the outside of the geo and starts bouncing around, which is fine. But if I go in here and I just increase this rest length scale to something like 4, it starts to blow up and fill up the object. Now it's like a little bit too dramatic for what we're after right now, but it's at least working. These objects are expanding, which is good. So maybe we can animate this over time. So instead of it, just going from a rest length of 1 and instantly popping up to 4, we could just alt-click and set a keyframe here. I'm going to just turn off the brain, and I'm going to go out to frame 72 and set another keyframe and set the constraint length to, let's just go with 4 for right now. Likely we're going to have to balance out how these are all like sort of interacting with we're just going to have to balance out not only the rest length changing, but other forces in the scene to get it to kind of do what we're after. So let's just go back. I'm going to turn the brain back on and click play and see what we get. You can see all these balloons are starting to increase in size, and they're starting to nudge and push each other out of the way, which is looking cool. And then it starts to get pretty gnarly. So I think that one thing that I'm noticing is it looks like that maybe we could modify some of the bend settings in the cloth constraints so that these aren't so prone to kind of turning into blobs like this. A little bit of that's okay, but I want to see if we can maybe control that a little bit better. Another thing I'm seeing is it looks like there's some piece of geo is like snagged down here because it's colliding with our external geometry. So I think what I want to do is just modify the input a little bit where we have this VDB combine happening that is clipping the outside of this with the inside. I'm going to just do a little bit of a VDB reshape STF. I'm going to do a little bit of a reshape on the external geometry of this shoe, I'm actually going to bring it down. I'm going to bring it in. We'll use an erode operation instead of a dilate operation, so we can actually have it kind of maybe clip a little bit into this into those geometry, so that when we subtract it, there's a little bit more of a gap between the actual geometry we're creating and the collision geo. So I'm going to do that and see if that fixes that as well. And then I'm going to hop down to our pressure constraints. Actually, I'll choose we'll go with the cloth constraint first. And in the cloth constraints, what I might do is increase the bending stiffness a little bit. So we're at a stiffness of 0.1. Something I found worked for me was just increasing that to 0.25. So it's just not going to want to fold quite as much. And then we could also go up to the stretch stiffness. That's good at 600. It's good at 600. I think that should do it for the cloth. And then under pressure, I'm going to kind of mess around with this. Now there's a compression stiffness that we haven't activated yet. And I think that the compression stiffness is basically going to help prevent these balloons from becoming compressed. Pretty self-explanatory. So let's just turn that on. I'm going to just set it down to a value of like 100. It's just trial and error. You eventually find values that work for that. And then also what I want to do is, because I've got this I've got this output group for this stretch constraint on the vellum constraints. I also want there's also these bend settings here. I just want to like create a group so that I can just when I'm working on this vellum constraint property, I'm only affecting the groups that I want to mess with, which is the stretch group. So let's also, on this pressure constraint, let's enable the output stretch group as well, so that we can actually tell this constraint property to use a group and only use the stretch group. So now we're only modifying that stretch group. So let's just check out what we've got now in terms of our simulation. So back over here in the DOP network, click play. You can see all of our balloons are increasing in size, and they're a little bit blobby. They're a little bit blobby yet, and I think that maybe what I would do to sort of counteract some of that is perhaps decreasing the amount of rest length scaling that we have going on here. So in the vellum constraint property, we're increasing to a rest length scale of 4. I might just drop this down to 3 and see what that gets us. So on frame 72, I just set that keyframe to 3 instead. All right, back to frame 0, and let's click play and see where we're at. So there's these haven't inflated quite so large, but they're still sort of kind of, I mean, it's doing a little bit better at not kind of becoming super squashed, but let's see if there's anything else we can do in that regard. One of the things that I think can be used to kind of manage this is to actually add a little bit of damping. So I'm going to just click on the damping ratio here and enable it. And I'm going to set this up to a value of 0.1. So really it's kind of adding a little bit of drag between each solve, which might help keep this a little bit more, help these balloons stay a little bit more inflated. Cool. It doesn't look like it helped too much in the end, so maybe I'll go back here to our cloth constraints and start messing around with some more stiffness stuff. I think before I get too far with continuing to fine-tune this aspect of it, what I want to do is add some more forces into our sim over here. So let's just bring in a merge. And I'm going to just wire in an axis force here so we can get that sort of orbiting motion as these balloons are kind of floating around. So let's do a pop axis force and wire that in here. And then we want it to rotate along the shoe, which is oriented along the x-axis. So I'm going to change the axis direction to be 1, 0, 0, like that. And then we'll go into the speed section. We can do an orbit speed of maybe, let's do 10. And then maybe we'll also use, let's just play that down and see what we get. So you can see that these pieces are rotating around. And but the axis is actually not centered on the shoe very well. So I'm just going to move the center of this axis a little bit. I'm going to grab this center right here. And let's just for a second turn on our collision geometry so I can see where the middle of our shoe is. I think that I just want to bring up this pop axis force to, somewhere around here. Looks like 0.33 is working pretty good in terms of it being in the center. So now it'll rotate about this axis instead of being slammed into the floor the way it was before. So let's go over here and play it down again. And I'm also going to turn off the display geometry on the collider static object because I want to see the bubbles. Click play, and they're orbiting around in there nicely. And they're inflating as well, which is good. And really taking on the form of that shoe after a while. I think that maybe I'll just try increasing the cloth stiffness and maybe damping ratio. Maybe we'll bring the damping ratio of the bend constraints up and then increase the stiffness to 0.5. And let's go back to frame 0 and play and see what we get if we get more spherified looking shapes. And it's looking pretty cool. I think that by the time we get to somewhere around here, I might stop the orbiting force. So let's just the axis orbit. Maybe I'll bring the axis orbit to 0 at frame 96. So let's go to the pop axis force over here, and at let's just go to frame 72. I'm going to set the speed of the orbit to 10, and then I'm going to click the brain to turn that thing off, and then go to frame 96, and then maybe bring the orbit speed back to 0. In fact, I might just middle mouse drag that frame 72 back to frame 48, just to give it a little bit more of a gradual slowdown. It should be good. So let's see what we get there. I think that also, I mean, right now it's just probably a matter of personal preference. I think that I could probably inflate these objects just slightly less than where I'm inflating them right now. And it might help prevent these sort of concave things from occurring. That might help. So I'm going to see what that does as well. Let's just bring the constraint property. We achieve a maximum I'm just going to turn the I turned the brain back on, but I meant to keep it turned off. So let's do that. Let's go up here. Instead of increasing to 3 less wrestling scale, let's go to maybe 2.5 instead. And let's see what we get now. The other thing I want to do is actually, now I'm thinking about it, in the static object, let's just decrease the amount of friction we have with the static object. I'll bring that down to 0.01 so it really can slide along that surface. So let's see what we get now with that. I'm going to turn the brain back on and click play. I'm really not 100% liking how these objects are getting super flattened out. Towards the beginning, they kind of pancake along the outside of this. I mean, that looks kind of cool actually, but in case you were trying to maybe avoid something like that, you could maybe add just a little bit of a suction speed to this. So I'm going to just turn the brain off one more time, and let's just increase the suction speed to something like maybe 3. Or maybe actually 5. So 5 should keep those spheres sort of towards the center of the shoe at the beginning. And then I'll keyframe this off also. Brain off. I'll keyframe this 5 down to 0 at frame 96 as well. So it's kind of following what the orbit speed's doing. Suction speed 0, and then alt clicking that. And I just want to see also if I just add a slight bit more of bend stiffness to this. I'm just going to go crazy with it just to make sure it's actually doing something. So on the cloth constraint, I'm going to crank the bend stiffness up to, like 10, just see what happens. Back to the sim, turn the brain back on, control click the brain to clear the simulation, and start one more time. See, the pieces are slightly, I don't see them kind of coming to the middle quite so much. But I'm liking the way that that's resolving in the end. Is the constraint, I'm not seeing the pop axis force now doing what I thought it was doing. So I'm going to just actually, let's see here. If I go out to frame 96, I'm going to open up my animation editor down here. And oops, you get this weird glitch. Sometimes that happens with me. It kind of sucks. So sometimes you got to click around to get rid of it. Hopefully that doesn't affect you too much. I hope they fix that at some point. But if I go back to now my my dope sheet right here, this icon, I'm gonna click my pop axis force and move to a frame where it's actually set to a value of 0 on the orbit speed. And now what I can do is I can actually just disable that. So now you can see that this is grayed out. So my orbit speed is going to be stuck at 0 even when I go back to frame 0. So I can kind of mute that animation track temporarily just to make sure that the suction speed is working the way I want it to. So let's go back to frame 0 and select a node inside of my DOP network and click play. And I can see that it certainly is sucking all those pieces towards the middle of my shoe, which is good. So I'm going to go with that. And let's just go select this pop axis force and then re-enable that animation property right there. And we should be good. So maybe I'll just increase the, I'm going to turn the brain off, go back to frame 48, and maybe I'll just increase the suction speed to something closer to 10 as well. So it kind of stays in the middle of the shoe, or more closer to the middle of the shoe. Let's turn that brain back on and see what we get. I think something went wrong with increasing the suction force, because now I'm getting all of these sort of like pillowy looking all these pillowy looking bends in my balloons, which I'm not interested in that. So we're going to just bring the suction speed back to where it was, which was a value of 5. And I'm not really 100% convinced that these cloth constraints are really doing what they're supposed to be doing. So I'm going to just try and see what increasing my constraint iterations is going to do. Let's go up to 300 and I'll click play. I'm just going to stop this. I don't want this guide around anymore. This pop axis force guide is kind of irritating. So I'm just going to untick that there. And let's click play. And that is looking good and bubbly to me. So what I think I would do right now at this point, I'm going to cache this out. So let's go over to our balloon export and into our Vellum IO here. I'm going to just create I'm going to rename this to a directory that I like to use, which is the cache directory. And then I put it in $OS, named after this operator, and $hip name as well. And so I can just kind of cache this thing out. It looks like it kind of comes to rest around frame 96, and actually a little bit after. I'll just cache it out to frame 120. So I'm just going to set the limit of my project to 120 down here, and that will correspond with this value right here. So I'm going to just cache this out now on our Vellum IO by clicking the Save to Disk button. And it's done, and let's just check and see what we can get with our Vellum post-process now. So I'm going to turn the Vellum post-process on, maybe give it a little bit of spatial blur to help round out those shapes a little bit better. And then maybe I'll add a looped subdivision like so. And it's kind of creating kind of some gaps between these different pieces. So what I like to do is sometimes when I'm smoothing geo out and things are starting to like separate too much, is I can just throw down a peak. And the peak will just move points along their normal. So if I just slightly increase this distance, I can kind of get them to be a little bit more snug as a post-process to just kind of dial in that look. But so imagine you've gotten yourself to this point and you're like, oh, but I want to add UVs. Well, you might think, well, you might have to go back and redo your geometry up here in this level and create UVs and stuff and send it back through your sim. But what we can actually do is use this geometry as a deformer and create some other geometry that has UVs on it the way we like. So let's explore how we can do that real quick. Hopefully quick. So we're going to want to take our original pieces here. So where's our original bubbles? These are our balloons to inflate. I'm just going to import this back over here. So let's just throw it on an object merge. And that way I can grab this balloons to inflate and bring it into our sequence over here. And we've got our balloons, the initial state of our balloons. They're not going anywhere. They're just static, which is cool. So then the next thing that we want to do is we want to actually sort of instance little we want to instance maybe some geo that we could apply UVs to each one of these individually and then deform them, but I found it easier to actually create little boxes. That way we can actually get UVs that's sort of like projected in terms of, we could spherify some boxes and basically project them onto these spheres so that they get nice UVs that are sort of planar mapped to each face of the cube. So let's just throw it on a box to start off with. And I'm going to throw down a for each loop. And we're going to do for each connected piece of this incoming geometry. For each connected piece of this incoming geometry, we can copy this box onto that point by using this cool node called extract centroid. The extract centroid will just compute a point at the center of each one, at the center of the incoming geometry. And since we're looping through all these different passes, it's going to do that for us at every point of the loop. So we get a centroid at each point. We could have just imported the scatter geometry that we created earlier back here, but I found that it was just handy to have everything, and recomputing this extract centroid just seemed to work fine. It was handy to actually have these pieces imported at this point for what we're going to do next. So we got this extract centroid. We just need to copy the points. And we want the actual centroids to be the second points, and we want to copy the boxes onto those points. So if we go to, I have single pass selected. I'm just going to go to the last. I'm just going to set all passes to go through, and then I just want to adjust the size of this box. Let's bring the scale of it down to, let's do 0.25. And then I'm going to actually make this a polygon mesh, and I'm going to increase the axis divisions to like 6. So we get sort of like a 5 by 5 grid on each face. And then here, I can add a UV unwrap. And this is going to do a 6-sided projection by default. And if I just throw down a UV quick shade, this just allows me to sort of see what the UVs are doing as they're mapped onto that object. Looking good. So now that we've got this UV unwrap and we're copying this onto all of our points, I'm just going to throw this UV quick shade down here. You can see we've got all these boxes with our UVs. I just want to smooth out these boxes a little bit to get them to look more like spheres so that they match closer to our topology. I accidentally hit the freeze button and undid that there. So now I'll just throw down a node that I really like for smoothing, which is the delta mush. And delta mush will allow us to input a step size. So the larger the step size, the more like coarse it's going to be in terms of its smoothing. And then I can also increase those iterations. So maybe I'll increase it to something like 30. And then I can do stuff like modifying the original scale of the box to try and get it to match. But I'll just go with this for right now because I'm going to actually be raying it onto our original geo. So maybe let me just template this. I want to get the raying operation works best when these objects are when they're closer in size. So maybe I'll just throw it on a transform here underneath the delta mush to bring up the overall scale of these boxes to something a little bit more in the ballpark like that. So maybe 1.75 seems to work. And then, so now we're going through all of these iterations. I want to just isolate one so I can focus on sort of doing one at a time. So now this isn't like a perfect sphere, and it doesn't by any means match up with this sphere, but we can use a ray. And the ray will take this geometry that we have, that we're copying, this box, and then we can ray it back onto the original geometry that's coming in. So now, we got to turn this to minimum distance. You can see now that it has taken that geometry from here and just kind of projected it inward onto that sphere. I find that this kind of looks a little bit warbly, so I just did an additional smooth on this to kind of smooth out the topology of those polygons and make it look a little bit more uniform. And then the next thing I would do is just to make sure I rayed it one more time. So I'm just going to copy this ray, wire the bottom in here, and wire the smooth into that. So now we've done 2 rays, but we've got this geometry that is quadded and really closely matches our original geometry like this. You can see that it's basically like almost perfectly matches it, but it's all made out of quads now, and it has our UVs. So now if I turn off single pass, we should get a bunch of really nice bubble geometry with all that, and it's all like mapped in there and looks all nice and stuff. And if I turn on UV quick shade, and let's just hide this template up here, you can see all these spheres look like they've got great topology, great geometry for applying textures and all that stuff. So that's really cool, but now it doesn't move with our geometry. So we just need to get this to link up with our original deformation, or with our original vellum sim. So I'm going to go up here and grab the vellum post process and peak nodes, and I'm going to drag them way down because we're going to actually apply what we're doing in between here. We're using a point deform. So point deform, I'm not sure if we've actually used it in this course or not yet. We've covered so much material, but the point deform takes in 3 inputs. The first one is the mesh that we're supposed to deform, which is going to be this mesh that we just created, all this stuff. So wire that into the first input. The second one is the rest point lattice. The rest point lattice basically is a static version of the geometry that's changing, so it has a rest position to kind of look at. So we're going to wire that in. The rest point lattice is going to be what we just imported, these balloons to inflate geometry. Because they're staying still, they will work perfectly fine as our rest geometry. And then the last input here is the deformed point lattice. And this is going to be the geometry that's coming from the sim. So I'm going to actually take this left input out of the vellum IO, and I'm going to wire that into the right input of the point deform. And when I highlight that and click play, you can see that all of these quadded out spheres that we created are now deforming along. But there's some issues here, and I want to just kind of diagnose this by I'm going to bring this up, bring a little bit more real estate over here. I'm going to bring up the vellum post process so it's closer to the point deform, and wire the point deform into the vellum post process right here. And then what I want to do is also template the input deforming geometry. You can see like this sphere is not behaving very well in terms of staying inside the realm of this other sphere. So the way we get that to work is down here in our point deform. It's set to look, it's searching for a radius of 0.1, and it's looking for points that are within that radius. It's looking for a minimum of 1 point in that radius and a maximum of 100 points in that radius. And if there's 100 points in that radius that are moving in all different directions, it's going to allow itself to be influenced by that many points. 100, I think, is way too much for this type of scenario. We actually don't want it to be influenced by that many points. You can see that because it was originally near all these other points, other spheres are having impacts on these deformations that we don't want them to have. So let's just bring that maximum number of points down. You can see that everything cleans up nicely. And now our geo is looking very much more under, the way you would expect if it was being deformed. So feeding that back into the post process and the peaking, I want to actually not use loop now. I want to use Catmull Clark so that it keeps that quadded look to it. And if I just go back here to our peak, I'm going to untemplate the Vellum.io so I can just focus in on this geometry. Maybe I'll actually just play this down and see if I see anything weird that we need to fix. So let's just increase that and let's go back to frame 0 and play it. And that's looking pretty good to me. And now if we grab our UV quick shade over here and wire it in right here, you can see we got all those nice UVs all lined up for us so we could attach whatever we want in terms of a texture and have it look kind of cool. I might increase the value of this peak slightly so that they're just a little bit more snug in there. But that's all totally up to you what you want to do with that. Super satisfying. Nice. So now having the quick shade on here, we can really just export this into an Alembic file if we want to do some rendering. So now we have, it looks like a bunch of attributes that we don't necessarily need. We don't need old P or name. So I might just delete those. And I think also at this point, I would probably just go and maybe subdivide this one more level. I'm not sure it's entirely possible. I don't know if that's really necessary. I mean, it looks pretty good to me initially, but I mean, I guess we can always subdivide it later, but I'm just going to do it. I'll just do 2 subdivisions. Why not? It's not hurting anything. And what we have here is this point deform is deforming this geometry that we just created. It's not taking all these attributes that we had here and copying it back on. In fact, we wouldn't get our velocity attribute if we just left it as is. But thankfully, we can recompute the velocity pretty quickly by just throwing down a trail and wiring that in here. So I'm just going to throw it on the trail and say compute velocity. And if I turn on the velocity trails, go back to some point where everything's moving quite a bit. If we wanted to get our motion blur back onto our Alembic object, we now have the data we need to do that, and it computes pretty quickly. So it's doing all this subdividing, smoothing, and peaking, and adding the velocity, and it's still playing back pretty close to real time. So now that we've got our velocity attribute on here, let's get rid of the name old P and P attribute by using this attribute delete finally. And we're just going to delete everything except for position, or except for velocity, and it keeps position by default. So we've got position and our velocity, and it's got our UV attribute here, which is good. So we can throw down a ROP Alembic output like this, wire it in here, and we're going to say render frame range, and I'm going to put it into hip abc underscore export. It's going to create a folder next to our project file called abc export, and I'm just going to name it after the current project file name. So that's going to be $hip name.abc, and that should be good. So I'm going to, the other thing I wanted to do before I do this is I also want to increase its size because of the way velocity attributes work. If I transform this, I'm not sure if it's going to actually transform the size of the velocity attribute, but going into Cinema, we want it to be a scale of 100 times more, and it looks like it scaled the velocity attribute for us. You can see right here, attributes, it says star, so it's going to scale attributes that it can as well. That looks like it'll scale vector attributes as well. So that velocity should all match up. So now when we export this Alembic file, I'm just going to pull down a null and say this is balloons. I don't even know if I'm spelling that right, but hopefully that's how you spell balloons. Well, yeah, it looks like based off of the shelf tool, I am spelling it right according to side effects, so that's good. So now I can just click Save to Disk. And I'm going to open up Cinema. And let's click Control Shift O, and I will navigate to the, let's go to our lesson files, 09B, wherever your project file is. And in the ABC export is where we just exported our Alembic file. So let's export that, or import that. Click OK. And here we've got our geo in Cinema. And it's animating and doing all that funky stuff the way it's supposed to be, except the frame range is wrong. I'm just going to change that to 120 and increase this. And if we stretch this all the way out to the end, see our geo fills in that shoe nicely. And we also have our velocity vectors here, which is good. We can use that to create motion blur. Let's go back to somewhere like right here. I'm going to click away from that. And let's just create a new material. I'm going to create a redshift material. We'll do material and put that on there. And I'm going to double click, edit the shader graph, and I'm just going to throw down something real quick so I can see the shading on this. See if the textures came through. So let's throw down a texture, and let's throw down a C4D shader. For the C4D shader, I'm going to wire this into the redshift texture under the generate image text 0 and output color into the property diffuse color. And the C4D shader, let's add a surfaces checkerboard. You can see our checkerboard showing up there. I'm going to just click on the C4D shader and click the checkerboard button and just increase the frequency. Let's do to 10 and 10, like that. And then I'll bring up the redshift render view and just fire off a render to see if that's all working. And it is. It's good. I mean, it's not the most amazing shader ever, but you can see that the UVs have come along and they're working properly, so that's good. The next thing is, let's just see if we can get some motion blur on this. So let's go back to, I've got this up. Let's go back to frame where things are moving quite rapidly, which would be maybe around frame 17 or something like that. Frame 22. And then what I'll do is let's go here with our Alembic. I'm going to throw down a redshift tag. We're going to call it a redshift object tag, and I want motion blur. We're going to enable motion blur, and we're going to add our velocities to X and Y and Z. Then we're going to go and open up our render settings, go to redshift, and let's go to the motion blur section here and enable it. And we're going to enable deformation blur, which is good. And let's hit the clapboard this time. You can see that we are getting the motion blur. It is all over the place. Usually what I got to do is go to this redshift object tag and bring the scale down to something like 0.1. And hit the clapper again. And you start to get more reasonable looking motion blur. That still might be a little bit extreme, but you can adjust that however you see fit. And that is sort of how we get a nice balloony, bubbly effect out of, we get it done first off in Houdini, and then we get it out back into Cinema as an Alembic file that we can shade and light and make it look all cool. So I hope that you thought that was fun. I thought it was cool. And in the next section, we're going to be exploring vellum grains, and we're going to be creating kind of a cool effect where we will be, working with particles once again. So I hope you enjoyed this. I hope you enjoy the next lesson, and I'll see you in the next lesson.